Hello everyone, in this video we will try to do some questions based on reducible to variable separable method. Let us firstly see how an equation with reducible to variable separable form looks like. Differential equation will be equals to some function which will be of the form ax plus by plus c. Here a, b and c are real numbers and can take any values. For example, in this question, right hand side of the differential equation holds a form in x plus y, where a and b are 1 and c is 0. In these cases, we let this x plus y is equals to t, and after differentiating with respect to x, this becomes dt by dx. Finding the value of dy by dx from here, it becomes dt by dx minus 1. Now, the given differential equation dy by dx is equals to sin x plus y plus cos x plus y becomes dt by dx minus 1 is equals to sin t plus cos t, implies dt by dx is equals to 1 plus cos t plus sin t. Now, using some forms of trigonometry, 1 plus cos 2 theta is equals to 2 times cos square theta, and sin 2 theta is equals to 2 times sin theta into cos theta. Comparing with the given form, we have 1 plus cos t, which becomes 2 times cos square t by 2, and sin t becomes 2 times sin t by 2 into cos t by 2. So, the given differential equation becomes dt by dx is equals to 2 times cos square t by 2 plus 2 times sin t by 2 into cos t by 2. Taking 2 times cos square t by 2 common, it becomes 1 plus tan t by 2. Now, rewriting it, dt by dx is equals to 2 times cos square t by 2 into 1 plus tan t by 2. Now, this equation have been reduced to the variable separable form. Now, taking the like terms on the one side, it becomes 2 times cos square t by 2, 1 plus tan t by 2 is equals to dx. I can rewrite it as secant square t by 2 divided by 2 times 1 plus tan t by 2 dt is equals to dx. Integrating both sides, it becomes log of 1 plus tan t by 2 is equals to x plus c. Now, please note that 1 plus tan t by 2 derivative is equals to secant square t by 2 divided by 2. Taking antilog both sides, the equation becomes e to the power x plus c. Now back substituting the value of t here, it becomes x plus y by 2 is equals to e to the power x plus c. This is the required solution of the given differential equation. Let us move to the second question, which is y by x dy by dx plus x square y square minus 1 divided by 2 times x square plus y square plus 1 is equals to 0. Here notice the pattern here is x square plus y square. Let x square plus y square is equals to t. Differentiating both sides with respect to x, it becomes dy by dx is equals to dt by dx. Now dividing both sides with respect to 2x, it becomes 1 plus y by x into dy by dx is equals to 1 upon 2x into dt by dx. Finding the value of y by x into dy by dx is equals to 1 upon 2x dt by dx minus 1. Now the given differential equation be y by x into dy by dx plus x square plus y square minus 1 divided by 2 times x square plus y square plus 1 is equals to 0. Substituting the value of x square plus y square as t, this becomes 1 upon 2x dt by dx minus 1 plus t minus 1 upon 2t plus 1 is equals to 0. We can write it as 1 upon 2x dt by dx is equals to 1 minus t minus 1 upon 2t plus 1. Taking LCM, it becomes 2t plus 1 minus t plus 1 and t plus 2 upon 2t plus 1. Let us rewrite the equation as 1 upon 2x dt by dx is equals to t plus 2 upon 2t plus 1. Taking the like variables on one side, simplifying the left hand side, let us add and subtract 4. It becomes 2 times t plus 2 divided by t plus 2 minus 3 upon t plus 2 into dt is equals to 2x into dx. This becomes 2 minus 3 upon t plus 2 dt is equals to 2x into dx. Integrating both sides, this becomes 2 times t minus 3 times log of t plus 2 is equals to 2x square divided by 2 plus c. Back substituting the value of t here, this becomes 2 times x square plus y square minus 3 times log of x square plus y square plus 2 is equals to x square plus c, which is the required solution of the given differential equation. For the next part, dy by dx is equals to 4x plus y plus 1. In this differential equation, we have 4x plus y plus 1, and let us take it as t. Differentiating both sides with respect to x, it becomes dt by dx. Finding the value of dy by dx, this becomes dt by dx minus 4. Now, the given differential equation dy by dx is equals to 4x plus y plus 1 whole square becomes dt by dx minus 4 is equals to t square. This is very simple now. dt by dx is equals to t square plus 4. Since this becomes variable separable form now, taking the like variables on one side and integrating both sides. It becomes half of tan inverse t by 2 is equals to x plus c. Multiplying both sides by 2, tan inverse tan t by 2 is equals to 2x plus c dash. Implies t by 2 is equals to tan of 2x plus c dash. Back substituting the value of t here, this becomes 4x plus y plus 1 is equals to 2 times tan of 2x plus c dash, which is the required solution. Let us do some statement based questions now. The question says the initial value problem governing the current I flowing in LR circuit when a step voltage of magnitude E is applied to the circuit is given by the equation this, where value of t is always positive, and we have also given that I of 0 is equals to 0. We have to find a solution I of t and the limiting value of I as t tends to infinity. Firstly, let us observe here is that my dependent variable is I, independent variable is t, Rest of all the variables are constants. Taking the differential equation, implies L times di by dt is equals to E minus R times I. The given differential is simply in variable separable form, so by default it becomes di by E minus IR is equals to dt by L. Integrating both sides, di by E minus R times I is equals to integration of dt by L. This becomes minus of 1 by R into log of E minus R times I is equals to T by L plus C. Let us mark this as equation number 1. We are also given that I of 0 is equals to 0. So using this, the equation number 1 becomes minus 1 by R log of E minus R times 0 is equals to 0 by L plus C. Here the value of C is equals to minus of log E divided by R. Back substituting the value of C here in equation number 1, equation number 1 becomes minus 1 upon R log of E minus Ri is equals to T by L minus log E upon R. Let us simplify this equation now. Taking log terms on one side, this becomes I plus log E upon R is equals to T by L. Taking minus 1 by R common, this becomes log of E minus Ri divided by E is equals to T by L. This becomes log of 1 minus Ri by E is equals to minus R into T by N. Taking antilog both sides, this becomes is equals to e to the power minus RT by N. Implies E into 1 minus e to the power minus RT by L is equals to I times R. As t tends to infinity, e to the power minus RT by L tends to 0, implies e of 1 minus 0 is equals to I times R, implies E is equals to I times R when t tends to infinity. For the next statement based question, The question says the temperature of the surface of a steel ball at a time t is given by the equation U, where k is my positive constant, and we have to show that U satisfies this differential equation. And after that, we need to find the initial temperature on the surface of the ball and what happens if we take the temperature to infinity. So let us firstly verify. We need to show that U of t is equals to 70 into e to the power minus kt plus 30 satisfies the equation du by dt is equals to minus of k times u minus 30. Let us mark it as equation number 1, taking u of t is equals to 70 into e to the power minus kt plus 30. Let us mark this as equation number 2, differentiating equation number 2 with respect to t, both sides. This becomes du by dt is equals to minus of 70 into k into e to the power minus kt. Let us mark it as equation number 3. Now, substituting the value of u and du by dt in equation number 1, right hand side of equation number 1 is equals to minus of k times u minus 30. The value of u here is 70 into e to the power minus kt plus 30 minus 30. 30 got cancelled out and it becomes minus of 70 into k e to the power minus kt, which is equals to the left hand side of the equation number 1. So, given equation number 2 satisfies the equation number 1. Now we need to find the initial temperature that is t is equals to 0. So substituting t is equals to 0 in equation number 2, we get u of 0 is equals to 70 into e to the power minus k into 0 plus 30. E to the power 0 becomes 1 and we are left with 70 plus 30, which is equals to 100. when the temperature is increasing rapidly, that is t tends to infinity, then u of t, where t tends to infinity, is equals to limit t tends to infinity 70 into e to the power minus kt plus 30. This becomes 70 into 0 plus 30, and this becomes 30 only. So when the temperature is increasing rapidly, then the value of u becomes 30. So this is all for this video. I hope you have made an understanding how you have to solve an equation based on reducible to variable separable method, and we have also discussed some statement based differential equation questions. Keep learning.